on camera. All right, good morning. Let me show the calendar here. Remember, we're testing not next Monday, but the next Monday, March 8th. Only one more topic to cover, really, inverse trig. So we'll review inverse trig today. That's pre-cal only. No calculus today, no derivatives, no integrals, just pre-cal. And so it's been a while since you've done it, but hopefully it seems familiar by the time we get through. Then Monday and Tuesday we'll take derivatives and antiderivatives. And then, let's see, depending on what class you're in, I may or may not see you next block day because of the school day, the SAT thing. But we'll review both of those days, and then we'll have a test on the following Monday. Then test on that Friday as well, but that's the group test, open note. Not open note, but group test. All right, so let's talk about inverse trig rules. So we just finished this in pre-cal. That doesn't really mean anything to you, but it's fresh in my mind because they just took their test last period over this. Inverse trig functions. So again, it's 5.6, A, B, and C. A is just the pre-cal stuff. Let's just see how much we remember. If sine of x equals 1/2, then what angle, or angles, plural, would that be? What angle has a sine of 1/2? I see people doing this, which is what you should be thinking about. It's on the unit circle. Yes, it is on the unit circle. That narrows it down, I guess.
90 degrees.
Okay, we got guesses flying in from all over the place here. Here's how I think about it. So I heard the right answer, but I heard all the answers, so that doesn't really clarify for you. 1/2, sine. Is sine the x piece or the y piece? Sine's the y piece. 1/2 is the short side. So wherever this angle is, I need the y side to be shorter than the x side. So it's the shallow angle. And so that means it is, now you know, I hope, pi over 6. Of course, that's not the only place that has a sine of 1/2. Where else has a y coordinate of 1/2? And if you want to get really creative, you could go backwards to get there. I know, you're like, why would I do that? Well, you wouldn't, but it does illustrate that there's far more than one answer to that equation. Like there's an infinite number of answers, depending on if you go forward or backwards, if you spin around more than once. So lots of options. Now that's a little bit different question than the inverse sine of 1/2. I mean, it's very much a related question, but it's not exactly the same question. The inverse sine of 1/2 says what angle has a sine of 1/2, but I can only give one answer. So we've got, for the equation, there's multiple answers, but when we phrase it like this, we can only have one answer. Which of those answers do you think they picked to be the one answer to that question? Pi over 6. I always pick the easiest one. So pi over 6. Not 5 pi over 6, not negative 11 pi over 6, not anything else, just pi over 6. Because when you're doing inverse sine, you're restricted, maybe this sounds familiar, you're restricted to negative pi over 2 to pi over 2. You're not allowed to have an answer from anywhere else. It's similar, maybe we should have led with this, but it's similar to if x squared equals 9, then x equals plus or minus 3. But the square root of 9 is only equal to 3. It's just like they decided, well, we only want one answer for a square root, so we'll take the positive one. And this still confuses people because they're like, yeah, but if I square negative 3, I get 9. Yes, but we only want the positive answer. Similar here. If it's written as an equation, then you can have lots of answers. If it's written as inverse sine, or I guess you could phrase that as inverse square, the opposite of square rooting, you only have one answer. And so today is about finding the one answer, not the multiple answers, but the one answer within the restricted range. All right, how about inverse cosine of negative 1/2? Well, it's definitely going to be something over 3, so I like that part, because if sine of pi over 6 is 1/2, then cosine of pi over 3 would be 1/2. So it's the reference angle's over 3. So if you're thinking back to reference angle things, you're right. Let's see, cosine is negative in the second and third quadrant. And I'm only allowed to have one answer. So 2 pi over 3, or 4 pi over 3, or you could call that one negative 2 pi over 3. But I'm only allowed to pick one of those. Which one do you think the mathematicians long ago decided that's going to be our one answer? 2 pi over 3. Because inverse cosine, is restricted to 0 to pi. You should put those on there. First quadrant's always positive, but then you got to pick up a quadrant that has the negatives in it. So sine includes the fourth quadrant, because if it included the second quadrant, they'd both be positive and you wouldn't have the negatives covered. It's sort of the reverse story for cosine. Always include the first quadrant. If you need to include some negative values, well, the fourth quadrant would not help you for cosine. You need to go to the second quadrant. What was that question, Carson?
No, the third quadrant. You can't go in.
You can't go in there.
Yeah, you have to go like around. You can't go past it.
You can never go in the third quadrant with inverse functions. Everybody's either in first or second, or first and fourth. Never the third. And if you are in the fourth, well, we'll see what happens right here. Inverse tangent of negative 1. So that happens in the second and the fourth. But they're going to pick the fourth quadrant. So negative pi over 4. And this is what gets people. That's not the same thing as 7 pi over 4. I mean, it lands at the same spot, but it's not the same angle. You've got to use the quickest way to get there. So negative pi over 4. So the picture for tangent is the same as the picture for sine. It's restricted to negative pi over 2 to pi over 2 for inverse tangent. So these three pictures are key. Let me draw one picture that covers all of them. So some of the trig functions are restricted to 1 and 2. That would be inverse cosine. And basically inverse cosine and his friends. So secant goes there as well, and cotangent goes there also. So your answer has to come from 1 or 2 for those three. The other restriction is 1 and 4. That would be inverse sine and his friends. I like the picture, but I guess you could write it as the the range. Either way. That emphasizes what you pointed out earlier, you're never in the third quadrant. If it's negative, then you're either in the second or the fourth, but you're never in the third. So let's just do some unit circle review here. So try those. I'll press pause and then we'll come back and see how much unit circle we remember. But first, number 4, where is the sine equal to negative root 2 over 2? Negative pi over 4. It's got to come from 1 or 4. It's negative, so it's the fourth quadrant, negative pi over 4. Now, what you were arguing about is tangent. That is the harder one to think about because it's sine over cosine, and there's a lot going on there. It's positive, so it's definitely in the first quadrant. But which one is it? Did you guys ever come to a conclusion back there? Pi over 3. Little bit of a tangent 3 trick here. The tangent of pi over 3 is square root of 3. The tangent of pi over 6 is root 3 over 3. So the tangent 3 trick is that if there's 1 3 in the angle, there's 1 3 in the answer. And if there's a 6 in the angle, well, that's like having 2 3s. So if you remember that, it might help you figure those out. And of course, it works backwards. If you're doing inverse tangent and there's 2 3s, well, 2 3s make a 6. So that's kind of just a fluke that it works out that way, but it's very convenient if you remember it. If not, you're stuck thinking about y over x and which one works, and you can still get there. Cosine of negative, or inverse cosine of negative 1. So where is the cosine negative 1? At pi. So today is a lot of unit circle review combined with knowing where you're allowed to look for your answer. All right, so part 2. I didn't even call the first part 1 like I should have. Those were unit circle problems. That was part 1. Part 2, up to, there's only 2 parts, so these would be not on the unit circle. These are picture problems. Some people like these because you just draw a quick little picture, and if you remember SOHCAHTOA, you can get these right. Plus, you don't have to know the unit circle. That's probably the biggest reason people may like these. The sine of the inverse tangent of 3/4. So that means find an angle whose tangent is 3/4 and then take the sine of it. Except that I don't really know, there's not an angle that I know of whose tangent is 3/4, but I can draw a picture of that. See, tangent is in first or fourth, but this is positive, so it's got to be in the first quadrant. This is probably not going to be to scale. What's tangent in terms of opposite, adjacent, and hypotenuse? Yeah, maybe we should have started with SOHCAHTOA. So let's draw a picture with opposite over adjacent being 3/4. So opposite is 3, adjacent is 4. Be careful, the opposite's always the y, the adjacent's always the x. Ooh, what's the missing side in this triangle? 5. And sine is opposite over hypotenuse, or y over r, 3/5. That is most people's attitude. Like, oh, I can do this because I don't need to remember the unit circle. You do need to know SOHCAHTOA, and you got to know where to draw the angle. But other than that, you're pretty good. Now let me do one that has a little bit of a trick to it. Cotangent of the arc cosine of negative 2/5. Okay, arc cosine. Arc cosine just means the inverse cosine. So sometimes people write that, some people write inverse cosine. I don't know why they ever wrote arc cosine, but it means the same thing as inverse cosine. Let's see, inverse cosine has to come from 1 or 2, but it's negative, so I'll draw it in 2. So Katoa, adjacent over hypotenuse. The negative kind of matches up there. It makes sense that the negative 2 should be the adjacent. Hypotenuse is always positive. How am I going to find the missing side on that one? Yep, a squared plus b squared equals c squared. It's so frustrating teaching this when students don't know the Pythagorean theorem and they think it's like a 2, 3, 5 right triangle and they start making stuff up. Let's see, 25 minus 4 is 21, so the square root of 21. And the good news is, because we're in calculus, that one won't reduce anyway, or simplify. But even if it would, we don't have to. So if we got square root of 20 there, or square root of 12, leave them alone. Even if you got square root of 9, you could leave that alone. It's fine. Cotangent is the flip of tangent, so adjacent over opposite. Adjacent is negative 2. Opposite square root of 21. And if you were in a previous math class, you'd have to fix that. It's so exciting. We don't have to fix square roots in the bottom. Best news all day. Come on, you know how to fix it if you need to. If you wanted to fix it, and it's good to know how to fix it in case it's on a multiple choice test and they fixed it. That would be the fixed version. But you don't have to do that. Again, unless it's multiple choice and then and that's the answer choice. All right, last one. Number 3, the sine of the arc cosine of 2x.
Find the integral of the sine of the arc cosine.
That's Tuesday, Nick.
Oh, okay.
Derivatives are Monday, integrals are Tuesday. Today is just inverse sine and cosine, because I know it's been a while. You're still remembering this stuff, and that's fine. That's why we're taking a day to do it. All right, what quadrant am I going to draw this picture in? 1, because it's positive. Cosine is so Katoa, adjacent over hypotenuse, except that I don't have a hypotenuse. So how could I sort of force that thing into a fraction without changing anything? Yeah, just put it over 1. So I can sort of make a match up by putting it over 1. So if you don't have a fraction, well, make it a fraction. Just put it over 1. So adjacent is 2x. Hypotenuse is 1. And I still need to find the missing side, and it's still a squared plus b squared equals c squared. A squared plus 2x squared equals c squared. So it's going to have x in the answer, and that's okay. So 1 minus 4x squared. So the square root of 1 minus 4x squared. So a little bit more difficult than previous ones, but only because x's are involved rather than numbers. So it's the same process. SOHCAHTOA, Pythagorean theorem, and then SOHCAHTOA again. Sine is opposite over hypotenuse, or y over r. So square root of 1 minus 4x squared over 1. Well, which means the over 1 isn't really necessary, but it's not wrong. So the main things for today are things you're, in theory, already supposed to know. SOHCAHTOA, I feel confident you're good on that. And then the other new thing, well, not new thing, the other review thing is the two different restricted regions you're allowed to look in or draw in for inverse sine or cosine or tangent. Page 372, 3 through 9, 15 through 25, odd applies to all of that. And again, if you're calc chatting, this is section 5.6. So Monday and Tuesday will also be in 5.6. Monday is taking derivatives, driving forward. Tuesday we'll drive backwards. The rest of the week we'll review, and then the next Monday we'll test.